Muy buenas tardes, bienvenidos y bienvenidas a una nueva actividad del Festival de Ciencia Puerto de Ideas Antofagasta 2022, presentado por Escondida BHP. Yo soy Valeria Fonsea, periodista a cargo de las comunicaciones en el Observatorio ALMA, y los invito a disfrutar de una actividad que promete ser fascinante. Se titula Oumuamua, la primera prueba de vida extraterrestre. De ello nos hablará Avi Loeb, quien fuera el director del Departamento de Astrofísica en la Universidad de Harvard por casi una década. Es doctorado en Física en la Universidad Hebrea de Jerusalén y autor de cerca de 1000 artículos científicos junto con exitosos libros. Solo el año pasado publicó Extraterrestre, la humanidad ante el primer signo de vida inteligente más allá de la Tierra, de Editorial Planeta, y Life in the Cosmos con Harvard University Press. Sin duda, hablamos de alguien tan prolífico como controversial. Agradecemos a la Embajada de los Estados Unidos de América por el apoyo en el desarrollo de esta actividad que está siendo transmitida en puertodeideas.cl y en YouTube. Good afternoon, Mr. Loeb.
Thank you for hosting me. It's a great pleasure to join you remotely. I actually visited Chile about a decade ago at the Magellan telescopes. It was wonderful. I loved the country. What I'll describe today is the content of my book, Extraterrestrial, and you can see the cover in the middle of this slide. And if I had to summarize it in one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. What you see on the right side is the cover of another book that I published last year called Life in the Cosmos. That is a textbook of more than 1,000 pages long about the scientific background for this exciting frontier of studying both primitive forms of life outside of the Earth, biosignatures, as well as advanced technological life in the form of technosignatures. And what you see on the left side is a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Science and Humanities. And it was taken by the German photographer Herlinde Quilbel, who came to my office at Harvard and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" Now, let me illustrate how we might want to address this question. And fundamentally, it's using the scientific method. And one example of how this method is applied is the context of dark matter. We don't know what most of the matter in the universe is. We call it dark matter for a lack of a better understanding. And the most popular version of that is called cold dark matter, so that the dark matter particles had very low temperature when structures like galaxies formed. And this model predicts that in the centers of galaxies, the dark matter density should become infinite. That is called the density cusp. But when we observe dwarf galaxies, small galaxies, we don't seem to find a divergence of the density of dark matter at the center of those galaxies. And also the number of dwarf galaxies does not match our expectations from this cold dark matter picture. So I suggested a couple of weeks ago in a paper a possible explanation for why this may happen. Perhaps the dark matter is organized into clumps, each of them weighing about 10,000 times the mass of the sun. And then these clumps would scatter gravitationally off each other and would smooth out the matter in the centers of dwarf galaxies. And because gravitational scattering depends on speed of the clumps, then it turns out that for very massive systems like massive galaxies or clusters of galaxies, this scattering is not very effective. It's only effective for the low speeds characterizing dwarf galaxies. So this is called self-interacting dark matter. And here the interaction is gravitational. We know that dark matter interacts gravitationally. That's how we find it. Now, the interesting point is that a few hours after I posted my paper, a professor from the University of Toronto sent me an email saying, "I have a way of ruling out your model by using streams of stars that are very thin in the halo of the Milky Way galaxy. If you examine them, you can check whether they are being disrupted by the clumps that I was suggesting. And I was very glad that he wrote this email. I thanked him for that, because even though he's motivated to rule out my model, he might actually find out that my model is correct by checking the data. Doesn't matter what motivates him, the data will speak for itself. And so that is the scientific method. There is an anomaly, a scientist tries to explain it, and then another scientist or the same scientist collects data that would be able to either rule it in or rule it out. That's how we learn about nature. Now, what did the scientific method teach us so far about the universe? Well, one thing we know is that half of all the stars, like the sun, host a planet like the Earth, roughly at the same separation. So there are more Earth-like planets that are habitable in the observable volume of the universe than there are grains of sand on all beaches on Earth. And that should give us a sense of cosmic modesty. Not only we are not at the center of the universe, as was argued by Galileo Galilei. He asked the philosophers to look through his telescope and realize that the Earth moves around the sun. They refused to do that, and they put him in house arrest so that other people will not listen to him. Today, they would have canceled him on social media. But not only that, also what we find in our backyard, the Earth-Sun system, is not privileged. It's not special. So when we see a picture of an emperor or a king trying to conquer a piece of land, and if you open the newspaper, you have such an example, Putin is trying to conquer a piece of land, that's not very impressive, because it's just like an ant trying to hug a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from. When my daughters were young, they were at home, and they thought that they're at the center of the world, that they are the smartest. And that's because they compare themselves only to the family members. But when we took them to the kindergarten, that changed their perspective, and they realized that there is a smarter kid on the block. So our civilization will mature by finding others. And my point is that Albert Einstein was not necessarily the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. What you can see here is a cartoon that was drawn on the day that Einstein died. And it shows the Earth with a plaque on it, Albert Einstein lived here, as if humanity is very proud of his existence. But it's very likely that there were smarter scientists on a habitable planet around another star, and those predated Einstein by 1 billion years, because most stars formed billions of years before the sun. And the civilization that benefited from their wisdom had enough time to launch probes, which within 1 billion years could have filled the entire Milky Way galaxy and reached the solar system as well. We know that most stars formed billions of years before the sun, and these probes could be equipped with artificial intelligence systems. I call these AI astronauts. And they could be autonomous without waiting for guidance from the senders, and they could outsmart us and survive for billions of years as they travel between stars. And they could have populated the entire Milky Way galaxy. So whether we live in such a reality or not is not a philosophical question. We can find the answer by looking through telescopes. We should not repeat the mistake made by philosophers who refused to look through Galileo's telescope because they knew that the sun moves around the Earth. And the first reported object, speaking about looking through our telescope, the first object from outside the solar system, the so-called interstellar space, was an object discovered in October 2017 that was given the name Oumuamua, because it means a scout in the Hawaiian language, and this telescope, Pan-STARRS, resides in Hawaii. This object was roughly the size of a football field. You can see it circled in blue here. But it turns out that it was not the first interstellar object discovered by humans. In fact, in 2014, January 8th, about almost 4 years before Oumuamua, there was a meteor that was detected by US government sensors just off the coast of Papua New Guinea. And it moved so fast that my student and I, Amir Siraj and me, wrote in 2019 a paper saying that the speed of this meteor was so high that it couldn't have been bound to the sun. So it came from outside the solar system. Just like Oumuamua, except this one is much smaller, roughly the size of a person, a meter size. And there should be about 1 million such objects like this meteor inside the orbit of the Earth around the sun at any given time. And we wrote this paper in 2019. Just last week, the government confirmed that indeed the uncertainties about the measurements of this meteor are very small, and you can see the letter on the left, such that at the 99.999% confidence, this is a meteor of interstellar origin that is unbound to the sun. So this was actually the first interstellar object that was discovered. Now, coming back to Oumuamua, we know that it was really unusual because it came from a special frame of reference called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars near the sun. And only 1 in 500 stars is so much at rest as this object was. And the sun was just like a giant ship that gave Oumuamua a kick, as if it was a buoy at rest on the surface of the ocean. And of course, the sun gave it a kick by its gravitational force. As the object was tumbling, as Oumuamua was spinning, every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that it has a very extreme shape. And we detected this object from the reflection of sunlight. That's very different from the meteor that was discovered by the fireball that it produced when it went through the Earth's atmosphere. So the Earth acts as a fishing net. In the case of the meteor, we can see objects much smaller than Oumuamua, but in the case of Oumuamua, it never collided with the Earth, so we could see it only as a result of the reflection of sunlight. And the best fit to the variation of the reflection of sunlight was that of a disc-like object, a pancake shape. But more interestingly, there was no cometary tail. This object was definitely not a comet. We couldn't see a tail of dust or gas around it. The Spitzer Space Telescope looked at it for any carbon-based molecules and didn't see anything. You can see the image on the top right, and it's basically just noise. We didn't detect anything evaporating from this object. And moreover, this object was pushed by some force in addition to the force of gravity from the sun acting on it. But since there was no cometary evaporation, no rocket effect, the question is, what is pushing it? And the force declined inversely with distance squared. So the suggestion that I made, the only reason I could think of, was that sunlight is reflecting off this object and pushing it. But that requires the object to be very thin, to have a large area for its mass. And I argued that nature doesn't make such objects, so maybe it's artificial in origin. Now, this object, Oumuamua, was strange in many different ways, and I described 6 anomalies in my book, Extraterrestrial. Now, what did the mainstream community suggest as an alternative to the artificial origin. There was a lot of pushback. People didn't want to discuss an artificial origin, but the alternatives were also quite unusual. They represented objects that we have never seen before. So one of the alternatives was maybe it's a dust of, it's a cloud of dust particles that is very fluffy, that is 100 times less dense than air. And because it's lightweight, it's being pushed by reflecting sunlight. The problem with this idea is that such a cloud would be heated by hundreds of degrees when it comes close to the sun, and it would not maintain its integrity because it doesn't have the material strength. Then there was a suggestion, maybe it's an iceberg, a chunk of frozen hydrogen, pure hydrogen, so we can't see it when it evaporates. The problem is that hydrogen evaporates very easily, so it wouldn't survive the journey in interstellar space by absorbing starlight. It would just go away. So then there was a suggestion, maybe it's a nitrogen iceberg, chipped off the surface of a planet like Pluto around another star. And the problem here is that there is not enough solid nitrogen to make a large population of chips, such that you would see one of them as Oumuamua. The fundamental question is whether Oumuamua was natural or artificial in origin. And the way I think of that is like walking on the beach. Most of the time you see natural rocks or seashells, but every now and then you see a plastic bottle that indicates a civilization that sent it. And perhaps Oumuamua was a plastic bottle among all the asteroids and comets that we often see. Now, in September 2020, there was another object discovered by the same telescope Pan-STARRS. It was given the name 2020 SO, and it was thought to be an asteroid, but it showed the same qualities as Oumuamua. It was pushed away from the sun by reflecting sunlight, and it didn't have a cometary tail. And a few weeks later, the astronomers who discovered it realized that if you go back in time, this object actually came from Earth. It was a rocket booster that was launched in 1966 by a lunar lander mission launched by NASA. And since it had thin walls, it had a large area for its mass. So that's why it was pushed by reflecting sunlight. So this demonstrates that we can tell the difference between a rock and an artificial object, that in fact, this object we know is artificial because we produced it. The question is, who produced Oumuamua? And the way I think of that is as a cave dweller finding a cell phone. The cave dweller would argue at first, since he is used to playing with rocks, that the cell phone is a rock of a type that he had never seen before. Just like arguing Oumuamua is a nitrogen iceberg, a hydrogen iceberg, or a dust bunny. These are things we've never seen before. But of course, if the cave dweller is curious, he might press a button and record his voice and realize that it's not a rock. I would love to press a button on an object that appears artificial. Now, one can calculate the chance of detecting equipment from other civilizations. It's very different from the so-known Drake equation for radio signals, because it's not like a phone conversation where we are trying to detect the signal from a counterpart who is active at the time that we are listening. Here we are looking at objects that may be around even long after the sender is dead. So it's more like archaeology. I call that extraterrestrial archaeology. And the number of objects we find is dictated by the volume of the survey times the number of objects per unit volume. Now, another approach is to use the Earth as a fishing net. And that involves interstellar meteors of the type that I described before. And here, it's the number of objects per unit volume times their speed that dictates the number that we will find. And of course, the number and speed may depend on the size of the object. There may be many more small objects than big objects. NASA never launched an object as big as a football field. Now, you have to multiply these numbers by another factor, which I call the Ostrich Factor. And this involves the likelihood that we would look up and search rather than behave like ostriches and not look at all. So if we don't search, the chance of finding something is zero. My bottom line is the likelihood of discovery depends also on us, not just on them. Now, on the surface of Mars, there is the Perseverance rover. That's a robot that is operated by engineers from Jet Propulsion Lab in Pasadena. It's not an AI astronaut, it's not autonomous. And of course, if we find microbes that may have existed on early Mars, we would be very happy because that is not a threat to human intelligence. We can feel superior, we are more intelligent than these microbes. But imagine the Perseverance rover bumping into the wreckage of an advanced spaceship that exceeds the technologies that we possess. That would be a blow to our ego. And a lot of people will be troubled by that. But my point is, again, it's not a philosophical question whether we are the smartest kid on the block. We can tell the nature of an object like Oumuamua by taking a picture of it, a high-resolution image, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. I would not need to write the book if I had a high-resolution image. And I would like to get such an image. That's why I established the Galileo project. And one of its missions is to rendezvous with another object like Oumuamua and take a high-resolution image of it. You can see such a picture on the right side that was taken by OSIRIS-REx, a mission to an asteroid called Bennu. And it will bring back material from the surface of that asteroid to Earth next year, 2023. It's clearly a rock, you can tell. So if we land on an object like Oumuamua, we can tell if it's a nitrogen iceberg or whether it has screws and bolts and looks like an artificial object. So the key is to date the next Oumuamua. And indeed, Chile is the key for that because the Vera Rubin Observatory will start operations in about a year, and it will have the legacy survey of space and time. It could identify interstellar objects like Oumuamua that do not look like asteroids and comets by taking a video of the sky with its 3.2 billion pixel camera. That would be an amazing video of the sky obtained from Chile. And I think of it as a dating app in the sense that we will not choose most of the objects. We will swipe them to the left. We will never date the objects, except for one, because a space mission to rendezvous with an object, an interstellar object, will cost about $1 billion. So it's just like thinking about going on a date that costs $1 billion. You have to be very picky. And I have actually an NFT project with Snow Crash that is starting now imagining what it would be like to meet such an object. Now we can look at the next Oumuamua also with the James Webb Space Telescope. Since it is located 1.5 million kilometers away from Earth, observatories on Earth and JWST will look at the object from different directions, and you can trace the trajectory of the object in 3 dimensions very precisely. We can also look for infrared emission from such an object and learn about its composition. And, you know, maybe Oumuamua was thin and flat because it was a leaflet carrying a message from another civilization. And it would be tragic if we miss a love letter in our mailbox because it may have an expiration date when we destroy the climate or perish in a war. The other thing I wanted to say is that when I go to Harvard Yard, I often see statues or paintings of past deans and presidents that wanted to preserve their physical appearance for future generations to look at. But these monuments make very little sense because eventually, in less than 1 billion years, the sun will burn up everything on the surface of Earth when the sun will expand, when it will evolve. And therefore, if you want to preserve something for the long run, you want to send an AI astronaut that represents you into space, and there it could last longer than the sun. So these are the best monuments, AI astronauts. I should also say that there is an embarrassment in space. We send the New Horizons spacecraft, and it carries a box that has 30 grams of the ashes of the discoverer of Pluto, Clyde Tombaugh. And his ashes are no different than the ashes of a cigarette. They carry no information because ashes are burnt up DNA. So I'm worried about an extraterrestrial finding this box and saying, what is this primitive ritual of burning the genetic information about a person that NASA wishes to commemorate? It would have made much more sense to send an electronic version of the DNA of that person, or maybe a stem cell, so that the extraterrestrials would be able to reconstruct this person. So my hope is to launch a faster spacecraft that will overtake New Horizons and apologize for this box. Now, in June 2021, the US government, the Office of the Director of National Intelligence, submitted a report talking about objects in the atmosphere that they cannot identify. They submitted it to Congress. And in June 2022, there will be a new office in government that will start operations and assemble data from all military personnel on objects of this type. And since the government cannot understand the nature of these unidentified aerial phenomena, it's the duty of scientists to explain them. And that's the second part of the Galileo project. We dare to look through new telescopes and figure out what these objects are, because extraordinary conservatism leads to extraordinary ignorance. And by now we have more than 100 scientists engaged in the project. It's funded by donations that I received to my research fund at Harvard from a number of very wealthy individuals who were inspired by my book, Extraterrestrial. And as I mentioned, the Galileo project has 2 avenues of research. One is these unidentified aerial phenomena, and the other one is exploring interstellar objects like Oumuamua. And we plan to build telescope systems that would do both. So one aspect is designing a space mission, and we are starting to do that right now. We received funding for doing that. And this part is being led by a member of the Galileo project, Alan Stern, who was also the principal investigator on the New Horizons mission. And the second part has to do with building telescopes on the ground. And the first system will be assembled on the roof of the Harvard College Observatory in the coming months. And we hope to have it operational by summer 2022. And it will have infrared and visible light cameras that monitor the entire sky at all times, together with passive radar system and audio system. And the data will be fed into a computer system that tries to look for objects in the sky and identify their nature, whether they are natural, like birds or lightnings or meteors, or whether they are human-made, like drones, airplanes, satellites, or maybe there are objects that do not belong to these categories that came from outside of this Earth. And this is the infrared and visible light camera. We are now in the process of assembling them. Now, Carl Sagan is often mentioned as saying, extraordinary claims require extraordinary evidence. My point is that extraordinary evidence requires extraordinary funding. If you are not searching, you will not find anything. And think about particle physics. We don't know what the dark matter is. And one suggestion was that it's the lightest supersymmetric particle. And the Large Hadron Collider at CERN was supposed to search for it. And it cost $10 billion. But we found nothing. It was a search in the dark. And so if we invest billions of dollars in the search for equipment from other civilizations and do not find anything in 40 years, then in 40 years, we will be at exactly the same point as dark matter searches are right now. And they are part of the mainstream of science. So my point is, let's invest the funds first before saying that we don't have extraordinary evidence. Because, you know, we did that with dark matter. We didn't have extraordinary evidence, and we invested the funds and didn't find anything. Of course, we can search for indirectly for civilizations, like looking for industrial pollution in the atmospheres of planets, or looking for city lights on the night side of planets. And I wrote papers on both of them. And there is a tension between the ability of a civilization to launch equipment into space and the risk that it may destroy itself before it does it. And so if a civilization destroys the climate or engages in a war that makes it perish before it sends equipment into space, then it will not be distinguishable from nature a billion years later by any means, because in a billion years, even if you have computer systems on the surface of a planet, they will be circulated, mixed with the interior of the planet by geological activity. And you will not find any trace that a civilization was there. So Enrico Fermi asked, where is everybody 70 years ago? And the answer is possibly dead. A lot of the civilizations that existed may have died by now. That's why it doesn't make sense to look for radio signals, but it makes sense to do archaeology in space. And we could find equipment that is space trash, like New Horizons will be in a billion years from now. It will not be operational anymore. Or we can find AI astronauts that are operational. And then the question is how to engage with them. That's a difficult question. We don't have a protocol. And it's very different from detecting a radio signal from thousands of light years away, because here the question is what to do with something in our backyard. We have to respond immediately. And who represents Earth? We need to establish an organization. And of course, the way we respond depends on the technological gap between us and the equipment that we find. We might not understand what it's doing. And if it's very advanced, a very advanced scientific civilization might be an approximation to God. It could produce life, It may be able to produce baby universes in the laboratory. These are qualities we assign to God in religious texts. And in principle, it could also give us a meaning to our life if our life on Earth was seeded by another civilization. That would be similar to orphans finding information about their lost parents. My hope is that finding that there is a smarter kid on our block will inspire us, because if you look at human history, most of the time you see a group of people trying to feel superior relative to others. And if we find a smarter kid on the block, that would make such a thought meaningless. And my hope is that it will encourage us to treat each other as equal members of the human species. Because the cosmic play is not about us. We tend to think that we are important. But we know that we came to exist only at the end, and the universe existed for 13.8 billion years before that. So if you join a play at the end of the play, it's clearly not about you. And since we are not at the center of the stage, and we just existed for a tiny fraction of cosmic history, many civilizations could have appeared and disappeared before we developed our modern telescopes and technologies. So the play is not about us. Let's search for other actors. Perhaps they have an insight about the nature of this play, and we can learn from them. Thank you.
Thank you, Mr. Loeb. Thanks a lot. But hearing you, it seems like we are the problem. I mean, we are not very clear about what to search in this archaeology work that we are doing, looking for a civilization. And also another controversy that you created is that we are not prepared to receive the extraterrestrial civilization. So how can we, if we are not able to find it, according to you, we are not able to receive them, according to you?
We can easily find it. As I mentioned in the example with a cave dweller, a caveman, the caveman, if he's open-minded, he could tell that a cell phone is not a rock, okay? The only question is whether he's open-minded. So, with modern science, we can identify objects in the sky, and if we have good enough resolution, we can tell, is it natural? Is it a bird? We can tell a bird. We know all the birds. We know how they look. We know how they move. We can tell if it's a drone or an airplane. We know, because we make these objects, we know how they move. And if it doesn't look like it's a natural object that we are familiar with, and it doesn't look like it's human-made, because, for example, it moves close to the speed of light and does crazy things, and you can get a high-resolution image, and it looks nothing like we produce, then it should have arrived from outside of this earth. And it's not a question of talking about it and convincing. There is nothing to convince. I mean, you just look at the image, you just look at the data, and it will become clear. The biggest problem, as you said, is whether we are willing to collect that data. Because look at the history of Galileo. The philosophers did not say, let's look through your telescope and figure out what you're seeing and argue with you about the interpretation of the data. They didn't say that. They said, we know the answer. We don't want to look at your data. Why? For political reasons, partly because the church controlled society, and this idea would violate what the church believed in, that humans are at the center of the world. And also philosophers believed what Aristotle said, the ancient Greek philosopher. So it was a political issue. Just like today, if most of society believes in something, and if someone comes and says, science says something else, then people have a problem accepting that. They would prefer to say, let's put that person, let's cancel that person, let's not listen to that person. And that's what happened in the days of Galileo. So my point is, let's be courageous and open-minded. Now, who is courageous? Kids. Kids. So all of us used to be kids. As kids, we didn't have a baggage. We were willing to accept whatever we learned by looking at our environment. So I say, we forgot how to behave as kids. You know, when I was a kid, the biggest trauma, or I should say frustration that I had, was sitting at the dinner table and asking a difficult question, and then the adults in the room would dismiss the question because they didn't know the answer. So they didn't want to show that they are vulnerable, that they are ignorant, that they don't know the answer. So they would just say, this is not an important question, shut up. Like a kid, you can tell that. And that was very frustrating to me. And I ended up being a scientist because that allows me to find the answer myself. I say, I don't care about people who pretend to be the adults in the room. I just want to find the answer. So if I have a high resolution image of Oumuamua and it doesn't look like a hydrogen iceberg, doesn't look like a nitrogen iceberg, doesn't look like a dust bunny, then I say, the hell with the adults in the room. They can say whatever they want. I have the image, okay? And I don't care how many likes I have on Twitter because the facts matter more than humans. I don't care about humans' approval. I just care about getting the evidence. That's the way science makes progress. That's the way we learn something new about nature. And really the problem for us is to be open-minded. And you can understand why experts are not, because experts worked for decades accumulating knowledge on a subject. So if there is something new on their territory, they want to pretend that they can explain it using their knowledge, okay? But even if the object doesn't look like a comet or an asteroid that we had seen before, the experts would still pretend to say, it must be natural, but it's an object of a type that we have never seen before, period. Don't speak about anything else. It must be natural. So I say to them, how do you know it's natural? If it's nothing like we have seen before, be serious, be sincere. It's nothing we had seen before. Why wouldn't you just admit that we need more data to figure it out? How can you say with certainty that it must be a nitrogen iceberg? And I'm willing to bet, that even if it's natural, it may not be any of these possibilities that were suggested. So we will learn something new, no matter what. Let's just collect the data. But the danger is that some people are so close-minded that they say, we don't need more data. Forget about it. It's not so important.
You have a very good anecdote with another colleague that you usually tell about how we are prepared or not to find exceptional things. Do you remember?
So there was a colloquium at Harvard about Oumuamua, and when I left the room together with a colleague that worked on rocks for decades, he said, Oumuamua is so weird, I wish it never existed. Now, that is the response of an expert that wants to pretend that he knows everything. But a real scientist would say, that's exciting. There is some anomalies to an object. We might be able to learn something new about nature. So it's exactly the opposite response to that of a kid that is excited. And that's the problem I have, that with all the adults in the room, that they're not open to new discoveries.
And the other criticism that I've heard from you, it's about how ridicule has been the talk about extraterrestrial life. Why you think it's not taken seriously as you are taking it?
Well, because the public is very interested in the subject. Now, of course, there are lots of speculations that come as a result of people that are not professionals, not scientists, that raise a lot of crazy ideas. And then the scientists say, we don't want to consider this subject because there is a lot of crazy things said about it. But my point is, if you look back in time, there were people saying that anatomy should be forbidden. We shouldn't operate people because the human body has a soul. Now, imagine if scientists would say, oh, there is all this crazy nonsense said about the human body. Some people say that if you open the human body, it would hurt the soul. And we don't want to deal with those people. Therefore, we will never examine the human body. So if that were the case, then where would modern medicine be? we would never find an mRNA vaccine to COVID-19 because we would never understand how the human body works. And my point is, science has an obligation to explain the reality that we live in, irrespective of what nonsense is being said by some people. That's irrelevant. The scientific method can be applied to any subject.
Yeah, that's true. And well, there's observatories being built, as you mentioned, here in Chile, Vera Rubin, that is being constructed around 100 kilometers far from La Serena in northern Chile. Is the largest digital camera ever made for optical astronomy. And why do you think it could be really useful in search of this extraterrestrial life? Because it can take a picture and detect it from the Earth?
Yeah, so the question is, if we find objects that were created by another civilization, what is the purpose? And some of them may be space trash that are not functional. Some of them may be seeking information. And of course, before we engage with any of them, we would like to figure out what they are doing. That would be the smart thing to do. And then we should ask how to respond to that. And, so again, it should be guided by evidence. And we will not know until we collect that evidence.
Part of it is, I understand that looking for evidence regarding the information of your paper about the object that you saw in 2014 that now was released by the US Special Command. And in fact, I read it today in the news, only today, because it was confidential until now, as you mentioned. It's true that you're planning a titanic task of finding its remains in the seabed? Can you tell us more?
So that's the beauty of this approach, where to chase an object like Oumuamua, to rendezvous with it, would cost $1 billion for a space mission. But if there is a meteor that came from outside the solar system, the fragments from the meteor, when it burns up in the atmosphere, land on the ground. And in the case of this interstellar meteor, the site where it landed was off the coast of Papua New Guinea, and we can localize it to within 10-20 kilometers. And in principle, we can scoop interstellar fragments from the ocean floor. The ocean is quite deep, 1.7 kilometers deep, but it's not very expensive to send equipment that collects the debris from an interstellar object using a magnet, because this debris is magnetic. It's different from the soil that makes the seabed, the ocean floor. And we can collect it and then examine it and bring it to a laboratory and tell the material composition of the object. And perhaps there would be some larger pieces that we can analyze. And we can put our hands on interstellar material, and that could potentially inform us whether the object was natural, maybe a rock, like the rocks we have in the solar system, or not natural, maybe artificial, because an artificial object would have a very different composition. One thing is clear, that this interstellar meteor was not made of pure hydrogen or pure nitrogen, because then it would have been evaporated very quickly. We wouldn't see the fireball that we saw, and there wouldn't be anything landing. And the light curve from the fireball was such that indicates that the object fragments. So we are planning to plan an expedition to go and search for the fragments on the ocean floor from this meteor from 2014. And, it would be the first time that the interstellar material would be analyzed in the laboratory, and that belong to a big object.
That would be wonderful. But as far as I know, you haven't lost all your hopes on Oumuamua, because even if it is out of the range of the most powerful telescopes on Earth to observe it, I understand that there's an initiative called from Stellar Studies called Project Lyra to send a solar sail type probe to reach it. Is that still going on? I mean, are you part of it or not?
Well, there was a scientific paper suggesting a method to potentially reach, but the problem is that Oumuamua itself is now more than 1 million times fainter than it was close to the sun. We don't know exactly where it is, and there should be more objects like it moving around, so it will be really difficult to find it. You will need to equip the spacecraft with a large telescope to find it. So it's not practical because to find Oumuamua will require to carry a very heavy telescope. And instead of chasing Oumuamua, I think it makes more sense to look for the next object that looks like it. And the Vera Rubin Observatory in Chile should give us opportunities of that type. So I would compare, this with a person that you went out on a date and you liked. You can be obsessed with that person and search in the entire population where that person is. That is a very difficult task if you don't have the information of where that person is. But a much better approach is to continue dating and finding, another person that looks like that person that you liked. And that's the approach that we plan to take with the Galileo project. And it offers a much better prospect for a future mission.
The Galileo project also aims to install telescopes with cameras to get that picture you're looking for?
Oh yeah, so the space mission will carry a camera, but in this case, we detect the object on its approach to the Earth with the Vera Rubin Observatory, but we don't need to chase it. We just need to send that mission so that it will rendezvous with the object as it approaches us. So that will not require very high speed because you just need to be at the right place at the right time when the object is passing by, and then take a close-up photograph of it, potentially even land on it depending on the relative velocity, the relative speed. But the idea is to get much better information about an object, and we could get it also with telescopes. Now that we know that such objects are so interesting, we can look at them more carefully from the ground or with the James Webb Space Telescope. There are lots of exciting opportunities in the coming years.
And there's one more. I don't know how you make it, but I understand you're also working with the breakthrough starshot to send a craft. Can you tell us more? I mean, there's so many things going on.
Yeah, there are a lot of things, and just to let you know, I had 2,500 interviews over the past year since my book came out. So there is a huge amount of excitement and interest around this subject. With Breakthrough Starshot, the idea is to launch a spacecraft at a fifth of the speed of light so that it can reach the nearest star, Proxima Centauri, within our lifetime, because that star is 4 light years away and it's the nearest star. And in order to get there in 20 years, you need a spacecraft that moves at a fifth of the speed of light, which is 1,000 times faster than all the chemical rockets that we had launched so far. So the question is, how can you get so fast? And one way to do that is by pushing a sail with light. You can, in principle, push it to the speed of light. And the sail does not need to carry the fuel with it because you're pushing it with light. And so the idea is to have a sail roughly the size of a person outside the atmosphere and to shine a very powerful laser beam of 100 gigawatt for a few minutes. And if the sail weighs a gram, it could reach a fifth of the speed of light in a few minutes across a distance roughly 5 times the distance to the moon. And we are currently working on the technologies that are involved. And it's a very challenging project, but we have to take the first step if we ever want to leave the solar system in our lifetime. Of course, you can send chemical rockets, but it will take them about 50,000 years to reach the nearest star. And that's the amount of time that elapsed since the first humans left Africa. So you need patience for that.
You also need patience, because I am amazed about the amount of activities you do at the same time. You just mentioned about the number of interviews. At the beginning, I mentioned the number of papers you publish. And we have mentioned many activities you are involved. And on top of that, you are also founding director of the Black Hole Initiative at Harvard. So it's like, how you find time to all of these things, even attend to Puerto de Ideas?
Well, I just focus on substance and do not waste time in trying to get likes on Twitter, social media. I don't have any footprint on social media. And, you know, just like in basketball, they often say, keep your eyes on the ball, not on the audience. So that's what I'm doing. And just to give you an example, last week, in addition to the letter from the government that confirmed this meteor, the interstellar origin of this meteor from 2014, that was actually the closest object that was ever discovered from outside the solar system, this interstellar meteor that came from outside the solar system. I was also on a press release about the farthest object that was ever discovered in the same week, one day separated from each other, the two press releases. And then that farthest object was a galaxy 300 million years after the Big Bang that was discovered. It may be a black hole, a very massive black hole of 100 million times the mass of the sun. And it's very exciting for me to be on the same week involved with my students and postdocs in two discoveries, one of the nearest object and the other one of the farthest object that were ever discovered from outside the solar system. And as you said, I'm the founding director of the Black Hole Initiative. That's another interesting area of research for me, black holes. But I do think that finding another civilization would be of much greater impact on humanity. Early on, I worked also on the early universe and the first stars, the first galaxies. I have textbooks on that subject. But I basically enjoy addressing questions about the big picture, you know, our place in the universe. And it's very gratifying that we can do that with science nowadays.
Yeah, you have criticized adults in terms of, I like people to be more children, very curious, or you say the current scientific culture is more focused on awards, or also I don't find much intelligence here, so I look it out there. So what would be the message for the kids, for the young people that are open in their mind?
So the message is maintain your curiosity and do not surrender to the pressure, the social pressure from the adults in the room. Just stay who you are. And the way I think of that is just like seashells on the beach. Seashells, each of them has a different color when it's born. You know, and what happens to them is they rub against each other as waves bring them together and they rub against each other. They lose their unique color and they break up into indistinguishable pieces that make up grains of sand on the beach. And that's what happens to people when they rub against each other through social media, through the way science is done, when they listen to what senior people tell them how to behave and so forth, and what ideas they should work on, they become indistinguishable from each other. And my recommendation to young people is keep your unique colors that you were born with. Keep your curiosity and open-mindedness, because that's the only way by which we can advance discoveries. And it's really unfortunate that academic culture is not encouraging it as much as needed.
At the end, this is the last question I'm going to place to you. What would you like to see before you die? What's your biggest dream?
I want to see a gadget from another civilization that is functional and to press a button on it and see what it does. And hopefully it will do some magic. I would love to see that. And, I'm working on finding such a thing. I don't know if we will be successful, but since we are taking the road that was never taken, there is a chance that we would find some low-hanging fruit. So my hope is that in the coming years, I will find something, and we will find something with the Galileo project, and it would look like magic.
We all hope that, and doubly you are working hard on that direction. So thanks so much, Professor Loeb. Thanks so much for this time and this conversation.
My pleasure. Thanks for having me.
Muchas gracias a todos por acompañarnos hoy. Les invito a seguir disfrutando de las actividades del Festival de Ciencia Puerto de Ideas Antofagasta 2022, que se desarrollarán hasta el 24 de abril. Pueden seguir revisando la programación del festival y de todo el contenido de Puerto de Ideas en su página web, puertodeideas.cl. Muchas gracias.